Okay. NET-200, and this is from 9/30/16, Friday. This is day 10, finishing up week 5. We talked all about protocols. And protocol, transmission control protocol, IP, TCP/IP, which really makes the internet work. We did some review. The message must be encoded, must format and encapsulate the message. We're concerned about message size, the timing in sending it, and the different delivery options for the message. Note that when you turn in your packet tracers, you have a PDF, you have the packet tracer file. This comes with packet tracer. This is a file you worked on, and then you submit the results and whether it worked or not. There is a video explaining that. Alright. This right here was an example. We talked about Curry's. They make doors, make door frames. And in the case here, they had a tower here, and they're able to send that microwave signal back and forth between those. And that's how they connect their two locations. Later on. So the key that we're talking about, like in that last example for Curry's, is that information must be formatted in a way that when it's sent, when it gets to the other end, it can interpret what it is. For example, I'm speaking English, and you should, if you speak English, you should understand what I'm saying. Alright, so I have a busy slide here. Let's get started. One of the things in our situation here, we started out, let's say you had a smartphone in the classroom. You could communicate to a tower, a cell tower, with your smartphone. Goes over to a switching station, which hooks it up to the right phone number and communicates to a cell phone, somebody else's. The signal here through the air might be transmitted differently than through wiring and connections, fiber connections between the towers, and then back to that same format so this phone can receive the signal. And then the two devices can communicate because of the protocols in between. You could have your phone connect to an access point using Wi-Fi. Now this communications protocol is different than this one. Once in here, we use a different protocol to run it through to firewall here, through the firewall here, and out to the internet. It's routers out on the internet, and how they communicate, this could be a different setup than this one. One might be through satellite, most of them probably through fiber, could be some copper involved. The internet has these tier 1 providers who allow communications between each other at no cost. We'll talk more about this later on, about the internet and how that developed, going way back to about 1920 or so, when Ma Bell first started AT&T, all the way up to 1984 before they got split up, and now how some of them have converged back together. Anyway, so Mediacom, if you're coming from home, that connects in. Mediacom then would connect into a tier 1, which will move their traffic through. Google, they may be their own provider. I think Facebook is their own provider connected into the tier 1s. Same thing with Canvas. Canvas has to connect in. So by the time you get to that server there at Canvas, some server in which all our material is stored, probably goes through Ethernet and etc., different protocols before it gets here, before it gets out here, and so forth. So, same thing here. We have a PC here, uses Ethernet to connect to the switch here, and then eventually runs through fiber here, it's copper here, and we connect out to the internet. All using different... When we deliver messages, by the way, this is the day we logged into Windows 8 all day for our work. Different delivery options. Unicast, you have one device communicating with another device. Unicast. Now you're not sure how this all works in the cloud in between, but you send a request to a web server and it sends the page back. A broadcast would be this device. Then if it broadcasts, that means it sends to every device on the network, and every device sees it. For example, when the computer does an ARP and it has an IP, and what it's looking for is a MAC address, a physical address, it sends out a broadcast, and then when it finds the computer with the right IP, then they'll send back their MAC address. A multicast, that's where you send it in and it only goes to a specific number of receivers via the network. So only the people who belong to the multicast receive that information. When we ping, we do an ARP request first, takes that IP, matches it up to a MAC address, and then we can use that MAC address to contact computers. We can show the ARP table on our computers via this command from the DOS prompt. Okay. A couple more key slides. In order to understand the TCP/IP model, we look at it this way. We've got a browser, which is an app, that can communicate in through this hierarchy using HTTP, Hypertext Transfer Protocol, into what we call the application layer. Then it meets the transport layer. It's going to figure out how to transport it. Is it going to is it something that needs to be streamed, or is it something that's going to check and make sure it got there? Unicast to websites are this way. If you're streaming a video, it would be this way. So how is it going to transport the information? Then where is it going to go via this internet layer? So you need an IP address. This will help also get the best path. And finally, you have to actually access the network. If it's wired, it's Ethernet, or it could be Wi-Fi. It could be the protocol where you actually access the network. Then your message is sent. Alright, so hopefully this worked. I got messed up there. So if you think about it, if we were to draw this out, you've got some browser software that's going to communicate into these layers So you've got, let's say, a URL you're going to send using HTTP, and then that's going to figure out how to transport it. Then we're going to put some addressing on it, and then if it's Ethernet, we're going to put a MAC address on and put it out on the network. When it gets to the other end, as this, it's going to take off the MAC address, look at the IP address, figure out where to go with it, how are we going to transport it, and we get connected to the application. And let's just say this was a web server. And then the process repeats, comes back to your browser, you do another request, and as the information moves, it doesn't necessarily go the same way. In fact, it wouldn't all go in one big chunk. It would be sectioned off. We'll talk more about that later on. So, now we can make a comparison with the TCP model and the OSI model. We tend to use the OSI model a lot. We take this application layer and break it into 3 parts. Get the application, how we're going to present the data, and set up a session. Transport is transport. It's either UDP, TCP. There are some other ones that we mention briefly as we go along, but we figure out how we're going to transport the information. Okay, and the information here is also split up into segments. Okay, then we apply an IP address of where it's going, the network layer. Here we look, the IP address gets us the path to where we're going. So now we moved from a segment. Now we have something a little bigger, it's a packet. And then we move that packet down, and down here we get a frame with this other information in it. That, and then we had this information, and all that where we keep adding on as we come down, called encapsulation. So data link, this would link us to the next hop, and physically how we're going to actually move the data. And the physical movement, how is it going to be moved across the wire, or how is it going to be moved across the fiber, or how it's going to be moved across maybe the Wi-Fi or the wireless, and etc. Okay? Alright. It takes time to get to understand how the information flows. These are models to give us a view of how it works. We're not going to go through technically how everything works inside the computer. But that information from a PC has to be organized in a form that it will move across the media. We can keep track, and then the address and so forth, and hit a router, and that router send it back, hit another router, that router send it back, and eventually it gets to where we want it to be on the internet. And then send the information back, and it wouldn't necessarily go the same route. Peer-to-peer communications, we're comparing to device. So these that we're using as an example would be unicast. And that is it. We're up to date.